I am Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I am going to discuss about the topic Kirchoff's current law, which is under the unit measure node analysis of electric circuit for the first year second semester under the course circuit analysis and devices. Introduction. In general, the circuits may be analyzed to determine the complete set of voltage and currents. Only two simple laws are needed in addition to the Ohm's law. The new law which are illustrated will be the Kirchoff's current law KCL and Kirchoff's voltage law KVL. There are simple restatements of charges and energy conservation respectively. The nodes, path, loops and branches. A point at which two or more elements have a common connection is called a node. In figure A, the node will be represented in 1, 2, 3. In figure B, same 1, 2, 3. Two or more elements which are having a common connection is termed as node. If no node was encountered more than once, then set of nodes or elements that we have passed through it is defined as a path. If the node at which we start is same as a node and which we end, which is simply the starting and ending point of the node is same, then the path is defined as the closed path or loop. Branch. The branch is a single path in a network composed of one simple element and the node at each end of that element. Thus, the path is a particular collection of branches. Now we are going to discuss about the Kirchoff's current law KCL. West Robert Kirchoff, the German university professor who was born about time Ohm, was doing his experimental work. The Kirchoff's current law, which is abbreviated as KCL, which states that the algebraic sum of the current entering into any node will be 0, which is summation of current will be 0. This law represents the mathematical statement of the fact that the charge cannot accumulate at the node. The node is not a circuit element and it certainly cannot store, destroy or generate charges. Hence, the current's sum will be a 0. The KCL law, the sum of current entering into node must be 0. However, the sum of the current leaving the node will be also be 0. So, might IA, the current entering IA plus IB, which is equal to current leaving the node IC plus ID. The sum of the currents going must be equal to the sum of the current going out. Example for narrating the KCL law, for the circuit compute the current through the resistor R3. If it is known that voltage source applies for the current will be 3 ampere. The circuit which is having the applied voltage of 10 volt and the resistance R1 and R2. In the R2 resistance will be having the current flow of 2 ampere and the current for the resistor R3 the current will be I. The total current of the circuit will be 5 ampere. First, we have to find 10 volt power supply is given to the circuit. The R1 will be having the current of IR1. The R2 resistor will be having the current of 2 amperes and R3 will be having the current of I. And the total current will be 5 amperes. So, in the node R1, the current IR1, R2 2 ampere. In the node R3, the current will be IR1 minus 2 amperes of current will be flowing. In R3, the current I will be flowing. And from 5 ampere current will be flowing to the circuit. Summing the current flowing into the node IR1 minus 2 plus the resistor R3 or current I plus 5 total ampere which is equal to 0. We know that the 10 volt source is supplying the 3 volt of power. Substituting we can get I, which is total current, which is equal to 3 minus 2 plus 5, which is equal to 6 ampere of current will be flowing in the R3 resistance. Thank you. Thank you.